This is the first problem set for logs. Chapter 4, Section A, page 110 reading. Graph the function 10 to the x power for x values negative 1, 0, and 1. Let's see, so I make an xy table and I put negative 1 into there. I get 10 to the negative 1, which is 1/10, which is 0.1. If I put 0 in there, then I get 10 to the 0, which is just 1. And 10 to the 1 is equal to 10. So if I graph that, I would graph 3 points. I would graph 0, negative, oh, I'm sorry, I did something. Let's see, I'm going to put the x-axis there, and I'm going to put the y-axis here. And then I'm going to graph here. Okay, so negative 1 comma 0.1, so that would be about here. 0 comma 1, that would be here. And 1 comma 10, that would be here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. All right. Very steep curve. Now it says graph the inverse function of the, or graph the inverse function f of f negative 1 x on the same axes, and you just find it by reflecting over the line y equals x. So I've drawn the line y equals x in green, and now I'm drawing the reflection of the red line in purple. So I took the point 1 comma 10 and I changed it into 10 comma 1, that's here. I changed the point 0 comma 1, I changed that to 1 comma 0, which is here. And now I'm going to take the point negative 1 comma 0.1, I'm going to change that to 0.1 negative 1, so that would be about there. Okay, so that's the reflection. Now let's fill in this table here. Regarding the inverse function, given the input blank, it will output negative 1. Given the input 0.1, it will output negative 1. Given the input something, it will output 0. Well, that would be that input, which is 1. Given the input something, it will output 1. That would be the input 10. Okay? Okay. Given the input something, it will output 2. And so given, if you look at the pattern here, first it gives you 0.1, then it gives you 1, then it gives you 10. So I would predict that to get 2, you would have to give it 100, because each one of these steps is multiplying by 10, right? 0.1 times 10 is 1, 1 times 10 is 10, 10 times 10 is 100. And then here I'm going up by 1s, negative 1, 0, 1, 2. Okay? Right as a power of 10, it gives me a bunch of numbers that are powers of 10. So I'm going to put 10, and I just put 4 because that's the number of zeros here. This would be 10 to the third, this would be 10 squared, this would be 10 to the first, this would be 10 to the 0, this would be 10 to the negative 1, because it's 1/10, right? This would be 10 to the negative 2. This would be 10 to the negative 3. Okay. Right as the power of 10, square root of 10. Well, the square root of 10, that's not as easy, but the square root of 10 is the same as 10 to the half. 10 times square root of 10, this would be 10 to the first times 10 to the 1/2, and since it's the same base, you can add the exponents, 10 to the 3/2. 1 over the square root of 5. Okay, so that would be 1 over 10 to the 1/5. Now remember, if you ever have a inverse like that, you can say 10 to the negative 1/5. What kind of number does not have a logarithm? Well, a logarithm, which is the opposite of a power of 10, you can see that if this purple line is a log function, it seems like everything over here to the right has a log value. But look how it has an asymptote. It like goes down here and never touches the y-axis. So what about over here? What about the negative x region? Is there a log for that? No, there's not. So what kind of number does not have a logarithm? A negative number. If we write an expression like log of 800, what base is the log in? Well, if you don't say specifically log base something, then it's assumed that you're talking about base 10. So we're talking about log base 10 here. How do you write in a math equation that the log base 10 of 1,000 is 3? Let's see, I would write that the log base 10 of 1,000 equals 3. And basically what log base 10 is doing, it's saying how many zeros are there in 1,000? For powers of 10, that's basically what it says. So in this case, we have 3 zeros, so the answer is 3. How many zeros in 100? 2. How many zeros in 10,000? 4. What is the log of 100? 2. What is the log of 10,000? And here we're talking about log base 10, of course. 4. Okay? So whenever you have a base 10 and you say, what's the log? Basically what you're asking is, how many zeros in that number? Okay? It gets more complicated if it's not an exact log of, an exact power of 10. Okay, so now let's take this one here. Log of 10,000. We just did log of 10,000. It's 4. Okay. Log of 0.001. Well, log of 0.001, that's 10 to the negative third. Okay. So the log of 10 to the negative third is the exponent. Okay. The exponent when it's a power of 10. Log of 10 would be just 1. Log of 1 would be 0, right? Because 10 to the 0 is equal to 1. Log of square root of 10. Well, 10 square root is 10 to the 1/2. So the log would be 1/2. The log of 10 times square root of 10, that would be 10 to the first times 10 to the 1/2, which is equal to 10 to the 3/2. So what's the log? The log is 3/2. And then this one here, when you have log of the cube root of 100, you would have 100 to the cube root to the 1/3. And then 100 is 10 squared to the 1/3. And then if you multiply those together, because there's an exponent to an exponent, it's 10 to the 2/3. So the log of 10 to the 2/3 is 2/3. Okay? The log of 10 times 10 to the 1/3, and since these are the same base, you can add those exponents, is 4/3. Okay? So if you can write the expression inside the log as an exponent of 10, then all you need to do is take the exponent, and that is the answer to the log. Basically, it's saying, what is the exponent if you express it as a power of 10? Okay, simplify these. All right, so whenever you have, let's see, a log of a power of 10, remember, you can just take the exponent, and that's your answer. If you have log of two things multiplied together, well, we can just make this into, it's 10 to the a times 10 to the, and it's squared, right? And if you have the same base, you can add those. So you could say 10, 2 plus a. And so the log would be 2 plus a. And this one would be log of 10 over 10 to the m. So that would be equal to 10 to the first times 10 to the minus m. That would be 10 to the 1 minus m, so the log would be 1 minus m, right? This one, 10 to the a over 10 to the b, that would be 10a times 10 negative b, so that would be 10a minus b, so the log would be a minus b. Use your calculator to write the following in the form 10 to the x, where x is correct to 4 decimal places. Basically what they're asking you to do is find the log of each of these. So you're saying, how do I write 6 as a power of 10? So what is this equal to? Well, to find this, basically you would say, hey, the log of 10 to the x is equal to the log of 6. Log of 10 to the x is x. So x is the log of 6. So all of these, basically, you just you type in your calculator log and the number, and it'll give you the log of that number. Let's go down to number 4. Use your calculator to find log of 3 and log of 300. So let's find the log of 3. We'll use the calculator, log 3, and we get 0.4771. And then we're going to do log of 300. Log 300, and we get 2.4771. Now that seems kind of a coincidence, right? 0.4771 and 2.4771. And then ask, why is the log of 300 equal to 0.4771 plus 2? Well, I guess it kind of makes sense because, like, look, the relationship between 3 and 300 is 1 is 100 times the other, right? 3 times 100 is equal to 300, right? And remember that logs are exponents of 10. So 10 squared is the log of 100. Or 2 is the log of 100. So can you see how if you want to change 3 to 300, you add the log of 100 to multiply by 100? Okay, so basically what we're saying is if you have if you have 300, you can break that down into 3 times 100. And 3 is equal to 10 to the log of 3. And 100 is equal to 10 squared. So if you could look at the bases are the same, so you can add the exponents. So you can write it as 10 to the 2 plus log 3. Okay? So now we can see that the log of 300 is equal to 2 plus log 3. Now you're not really going to understand that fully, but that's you'll get there. Now likewise down here, why is the log of 0.05 equal to the log of 5 minus 2? Again, with the exponents, remember that if you have 10 to a certain power, and you have 10 squared in the bottom, how do you find the result? Well, what you do is you subtract the 2 from the what's on the top, right? So if the x is 5, or if the x is log 5, then this would be equal to 10 to the log 5 minus 2, right? And remember, 10 to the log 5 is the same thing as 5. Okay, so basically this is saying 5 divided by 100 is equal to 10 log 5 minus 2. Okay, and now all these, they're just asking you the opposite now. So what the log of what number is 2? Now remember, log of 100 is 2, right? So that would be 100. Log of what number is -1? So that would be 1/10, right? Log of what number is 4? That would be 1 with 4 zeros. Okay. Log of what number is 1? 10. Log of what number is a half? Well, that would be 10 to the square root of 10 to the square root of 10, right? Because 10 to the 1/2, right? This would be 10 to the 0. This would be 10 to the -1/2. Okay, which would be 1 over the square root of 10. Okay, and then you got some of these funny numbers here. Now the way you're going to find these is, okay, I'm going to take log of x equals 2.14 2.1457. So what I'm going to do is I'm going to take 10 to that power and 10 to that power. So that's going to give me x, and this part is going to be 10 to the 2.1457. We'll use the calculator for that. Go 10 to the 2.1457. That'll give us 139.9. Okay? So that's how you do these. You just say, oh, I'm going to take 10 to the log x equals 10 to the negative 1.378. 10 to the log s is just equal to x. So you just do this operation in your calculator.